Okay, so new case study, and this time our company is GetTaxi. And GetTaxi is a company and it allows people to match with taxi drivers on demand right away. And the business comes to you and say, we want to build a business and we want the following capabilities. The user should match with a close-by driver. The pricing should surge if the numbers of drivers are low or the number of users is high. And all the position data before and during the trip should be stored in an analytics store so that the cost can be computed accurately and we have access to the data for whatever data science we need to do. So again, take some time to pause and figure out how you would implement this using Kafka. Got it? All right, let's get to the solution. So just a proposition of the architecture, but I'm thinking there should be a user position topic. And user position is a topic that contains all the users' position when they open their app and leave it open, because we need to know where the users are, right? So here's my user application and it needs to get into Kafka. So we never connect applications, mobile phones directly to Kafka. We always use a service as a proxy. And so I'm thinking there should be a user position service receiving data from the user application. And that service is going to be a producer for our user position topic. So we get high volume of data here. Then there should be the taxi driver application. Similarly, that's going to produce through a service to the taxi position Kafka topic. So these two feeds are going to be quite high volume, to be honest, probably even more volume from taxi than users. That's very, very good volume. And I chose to make them two separate topics because I think that a user and a taxi driver are very two different entities. Now, what we're going to get out of it is the search pricing topic. And so for search pricing topic, we need to take user position and taxi position into account. So I'm thinking that we should have a search pricing computation model with simple or maybe complicated rules using Kafka Streams or Apache Spark if you want to. So this user position and taxi position will both be read by the Kafka Streams application and it will output to one topic, which is search pricing. So something you note with Kafka Streams is that it can take as many input topics as it wants and perform whatever computation on them. Now that we have a search pricing topic, we can definitely feed it back into the user application to give them a cost of the service or an estimated cost of the service. And for this, we'll create a taxi cost service, which is going to be a consumer of our search pricing. And finally, to make our data science super happy, because they really want to get all this information as well into their analytics databases and stores to just do whatever they want, then should use maybe Kafka Connect. And this time, instead of Hadoop, maybe our analytics store is Amazon S3. So there is also a Kafka connector for doing this. So this is a typical one. I think this one is different from the other one because we get a Kafka Streams that reads from two topics, not just one. But it's still a very interesting example. And now a few comments. Taxi position and user position topics are topics that can have multiple producers. To me, they should be highly distributed, especially on high volume. Imagine how much there must be demand for Christmas or New Year's Eve, that kind of stuff. If I were to choose a key for the user position, I would choose user ID. And for the taxi position, I would choose taxi ID because I definitely want to get my data for my users and my taxis in order. And data is quite ephemeral and probably doesn't need to be kept for a long time in Kafka. So I don't need a really, really long retention period, okay? And that probably helps me because I don't need to store as much data in Kafka. Now, the search pricing topic is something that comes from the Kafka Streams application, and it may be regional. And so that topic may be high volume, for example. And maybe other topics that were not represented before, but such as weather or events, they can definitely be included into the Kafka Streams application for better accuracy and enhancement of our model. Okay, so these are the comments. Hope you like this example. Hope you get it right. And I will see you in the next lecture.